Welcome back to our live training session here. We're going to be taking a look in this training module how to dial in our full throttle operation. So this is going to be taking a look at fuel, spark, variable cam control. Now we're working with a K-Series engine here, Honda K-Series engine, and we will have VTEC to deal with, but we're going to take a look at doing the high cam or VTEC tuning in the next training module. We're going to be breaking this down very specific so you can see this calibration process to dial everything in properly with our fuel tech. So let's jump in here and talk about where we're at, the goal of what we're trying to accomplish in this training module, and just understanding overall the general tuning approach to dialing in our K-Series engine with our fuel tech. So first things first, we're going to jump here into the main fuel table. We know in that last training module, we dialed everything in here from roughly -2.5 PSI and below up to right around 6,500. So everything in here is essentially hitting the desired air fuel that we've set in our closed loop target air fuel table, and we're finding that the closed loop correction is making minimal adjustments. Plus or minus 5% is pretty normal in the O2 correction. That means we have a pretty well tuned main V table, or main fuel table I should say. So what we're going to focus on in this training module is dialing in the last few rows here of the table. This is going to represent our full throttle fueling. Now what we find is that we've carried through some of our values here into the upper higher load range that I've set for the table. We're going to go figure out if they're valid or not. So we're going to be using the same tuning techniques as we found in the last training module, either doing manual updates to the table, going through a data log, or using the O2 overlay option found in the FT data logger software. So this is going to be pretty simple and straightforward to deal with the fuel tuning. But let's talk about the two other variables that really account for giving the engine a lot of power when I'm under full throttle. That's going to be spark timing and variable cam control. So let's move here into our spark timing table. We can see right here, ignition tables. We've dialed everything in part throttle using the mainline dyno to figure out maximum brake torque timing from roughly -4 PSI and below. So everything here in the table has essentially been dialed in here for spark timing. Now, when we get into full throttle, that's going to be here the last few rows, this is where we've set things pretty conservatively. We've done this so that we're able to tune the fuel first and then come back into the spark timing last and start to increase the spark timing to increase the cylinder pressure in a safe, controlled manner. We don't want knock to occur where the engine can be damaged very easily, so we want to be very conservative with the way we approach this. 14 degrees of timing is probably about half of the ignition timing I would expect at full throttle with our Honda K-Series engine. We'll have to sort this out. Again, this is going to be one of the last things that we deal with. Now, starting off with low spark timing like this, we're going to have really low power output of the engine. That's okay, not a big deal. I'd rather be safe and dial in the fuel table than just jumping in here and running high spark timing and kind of doing everything all at one time. It makes things a little bit chaotic and not organized for calibrating and tuning. So we're starting off with a conservative value to keep things safe, keep things in order. All right, let's move down here into the last variable that we have to account for, which is really, really powerful for the overall power band out of the engine, and that's going to be the variable cam timing. We can take a look down here under intake target. Now in part throttle, we set our part throttle variable cam targets here at roughly 30 degrees as we're in cruising conditions. This gives us the balance of economy and throttle response. It's going to work for pretty much any K-Series engine. Now, if we take a look at the last few columns, these are all zeroed out. We need to determine what is going to work for the engine and the overall the parts that are installed on the engine. Every engine in terms of the K-Series or any engine with variable cam timing is going to be a little bit different in terms of what it wants for the values depending on how well the engine can breathe. In my situation, I have a 2 3/8 inch exhaust, which is going to choke up the engine a little bit. We'll probably find that the engine doesn't respond very well to high cam targets here, or a lot of overlap at high engine speeds. So we're going to learn how we can dial this in and actually build a proper cam composite blend, not only using the mainline dyno to see the before and after as we're changing things, but taking a look at our log data if you don't have a chassis dyno to do your tuning process. How do you determine if your variable cam control change is correct or not? And we'll determine that as we unpack all of the data logs and go through the tuning process. We're actually going to be looking at the log data and making some educated guesses as to what is going on with the power band. And then we'll take a look at the mainline screen and actually look at the dyno pool to see if what we're finding from the log is matching what we're seeing actually measure with the engine's power output. And finally, we'll build that cam composite blend. The last thing we're going to do here, after we've dialed in the variable cam timing, is jump into the fuel table and then completely calibrate that. So we want to make sure that the variable cam timing is dealt with first, then we can do the final tuning changes on the fuel table, because the variable cam timing affects the cylinder filling, affects essentially how much airflow is getting packed into the engine, and therefore that'll affect how much fuel we're going to need. So if we have our cam composite blend built out to give us the broadest, best power band possible out of our engine, once that's done, we can finalize dialing in our fuel table. Then we can finalize dialing in our spark timing. So it's going to move in this specific order of operations. So we'll dial everything in here, our fuel table, at 0 degrees as a baseline. Then we'll walk our variable cam timing up, figure out the cam composite blend, dial the fuel table in again, then touch up the spark timing and get that sorted out. So that's going to be essentially our goal here at the end of the tutorial, is to make sure that we have the best power output possible and broadest power band possible out of our engine with the combination of parts that we have installed. Okay, we're going to unpack all of that entire tuning process here in this training module. So we should be all good to go to do our pulls. We want to go in right now and set up the mainline chassis dyno. We're going to jump in here. I'm going to talk about the setting configurations. Even if you're not using a mainline dyno, it's just going to give you the information so you understand what's going on here. And then we'll do our initial pull. We'll log it. We'll play it back. We'll go through that process and just start to unpack everything, get everything sorted out. And then we'll just kind of rapid fire through all the changes to see how this is going to go from start to finish. We're going to have really poor, probably lackluster power output out of the engine. That's fine to begin. And then as we start to make our changes towards the end, we should see a pretty substantial difference in power output once we have that variable cam composite blend built, and we also have the spark timing dialed in. So we have our cylinder pressure in check, and the engine should all be dialed in at that point. So let's jump here and take a look at the mainline dyno screen, and let's set everything up here. So jumping into the mainline screen, this is going to be the main run screen for the mainline. This is where we do the part throttle calibrating process, doing any kind of maximum brake torque, dialing and tuning. We looked at this in the cruise video, the end of that video, the last video. We were looking at our torque side. This is our live torque output. Now what we're going to do is shift from here into the actual dyno pull mode. So if I go here and do F2, that's going to put me into my dyno screen. We're going to go here to setup. We want to set the dyno up so it knows where to start and stop the run at, and then how much duration or load we want to put on the engine. This is all very specific, so we want to make sure we're not revving the engine much past 65, maybe 7,000. With the VTEC unlocked. Much higher than that, we can get rocker float with the engine, and we want to make sure the VTEC is definitely engaged by that point. But for right now, we're not going to rev it much higher than about 65, 6,800, and we'll start our run at something lower, maybe something like 2,200 RPM should be sufficient. We also want to make sure that we're keeping a reasonable load on the engine. We don't want to have too little load that won't produce good repeatable results, dialing in something like spark timing or variable cam control. But we also want to make sure that we're going in and not having too much load, which could cause knock and pre-ignition and not allow us to really dial things in. So we want to be reasonable with our load. So if we take a look here, a couple things. We have our start speed, we have our end speed. This is where we want to begin and end our run at. Now, what we have here listed in the white values, we can see right here, 450, 350, 300. This is hub speed. So this is a hub dyno. This would be the hub RPM of where it's going to actually control the hub RPM. We can see here, because I've entered in the gear ratio to the mainline beforehand. I'm not going to go show that on camera here, but I've entered in the gear ratio so it knows what we're going to be doing our pulls in fourth gear. It knows the ratios for the transmission. Therefore, it can translate hub RPM to actual engine speed RPM. I actually don't have a tach pickup on the engine. It's doing everything by knowing purely the hub speed and the gear ratios. So we're going to find it's going to convert the start speed here down below to an engine RPM. This is where we want to start our run at. So right now, 2100 is fine for the start of the run. The end speed here, again, this is hub speed, and this is going to be the engine speed. This is the actual engine RPM. We're going to stop our runs right around 67, 6800. So anything below 7,000 is fine. So we have our start and end speed set. Now we can take a look at our duration time. The duration is how long it's going to take to go between this start RPM and this end RPM. So we can see right now the duration is showing 6.8 seconds. That's controlled here from our ramp rate. The ramp rate, this is how many hub RPMs per second it's controlling at. That gives us this duration time from the start and the end speed. Quite different than a normal roller style dyno. So if you're used to a dyno jet, it's definitely a lot different, and we need to make sure the duration is reasonable. 6 to 7 second duration works fine for most engines. I like to keep my duration time in that range. We can see right here we're at 6.8 seconds, so we're right in that range of 6 to 7 seconds. So the duration equates to the engine load. Too low of duration, too little load. too high of duration, too much load. 6 to 7 is about in the middle, it's about average. That's going to be what we shoot for here. I'm going to click OK, and the dyno is set up, and I'm going to go here to begin, and this allows the dyno to go ahead and begin its dyno mode. So all I have to do is fire up the engine, hit the space bar, and we start our run. Go full throttle, and we start our run. It'll control the engine all the way up to that peak RPM. It'll stop it. It won't let the engine over rev past that point, and then we can come back in and review the data log and review all this information. Let me go ahead and fire up the engine here, so I'll make sure I'm out of gear. Now, sometimes when I get odd starting like this, and I've mentioned this probably before, I have to do a key cycle. There's some weird problem with the main relay that I've noticed that sends power distribution to the harness. Engine speed there looked like it was actually, as I was cranking, looked pretty reasonable. It wasn't skipping out and dropping out. But what I find is that for whatever reason, the way that I'm controlling the main relay with the car with the fuel tech does something odd, and it doesn't allow the car to fire off. Let's go ahead. I'm going to go just power down. You can see the battery voltage has dropped to almost nothing. Let me power it up. Fuel pump's primed. It usually starts when it has this situation here. So let's try this again.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.